When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
What happens if you put an alkanoic acid and an alkanol together and a reaction forms? What happens in that reaction? That's what we're going to discuss in this video. So here we have an alkanoic acid represented by R, which is meant to be the length of the chain. So there might be 6 carbons, 7 carbons, doesn't really matter. That's our R. And we have the carbonic acid or the carboxyl acid group, which is COOH. Now when that joins together with an alkanol, again the R refers to the length of the carbons, the amount of carbons there are, doesn't matter how many, just however many, and the hydroxide group, which is the alcohol group. That's our alkanol. Those two join together. How do they join together and what forms? In this case, they join together by removing a water molecule, which we call condensation. So we have this here coming together and being spliced out. So this will leave as in the form of H2O, and then you're going to have the rest being joined together. So I'll do that now. So we have our R still. We have our carbon. We still have that double bond here that hasn't left. We still have one of the O's, right? So one of the O's is still there. But now I'll make this be removed. This is going to be condensating out. So this will be gone. And all we have left is that our alkanol group, which will attach to this O. Oops. And now we have our ester being formed. And what has left, what has condensated out, again I mentioned it, is these molecules, H2O, which equals to water itself. So it's this here plus H2O. We call the first, call this the ester. This was our ester. Because the ester is when we combine an alkanoic acid and an alkanol together, we call it the ester. And we have a condensation reaction happen because we have a water molecule leaving in the process where they join. So at the point where they join, we have the water molecule condensating out. So I'll read the actual dot point. It says identify esterification as the reaction between an acid and an alkanol, and describe using equations examples of esterification. Right, so here this is what I just quickly described esterification. We've got our alkanoic acid, we have our alkanol, and then they join together at the O of the alkanol, the acid, and now they're joined together, and in the process we have that water molecule condensating out. But I'm going to still go into a bit more detail and just give you an example. Right? So we'll cover actually the content of maybe 2 videos back where we had the nomenclature for alkanoic acid and alkanols and for esters. So first we'll have to figure out what these molecules are actually called. In this case, okay, we can see that it's got the carboxyl acid group. So this must be an alkanoic acid. It has 1, 2, 3, 4 carbons. 4 carbons makes it a bute. So we call it the bute. And it has a straight chain, so it's a butan. And then it's the acid, butanoic acid. This here is the butanoic acid. Bute standing for 4 carbons, and standing for a straight chain, and oic acid referring to it having the carboxyl acid. So it's butanoic acid plus, what we call this? Well, it has the OH group, therefore must be an alkanol. It has 2 carbons. 2 carbons is F, and then AN because it's a straight chain, and the O part means it's ethanol. So we've got F, 2 carbons, AN straight chain, O being the actual hydroxide group. So we've got butanoic acid plus ethanol, and what forms? Well, this creature here forms. This is our ester, and what we have to still do, we have to name that ester. In this case, we said earlier, what we start with, the first part of the name is the actual alkyl group, which is the alkanol. So here this is you can see here they attached here with this attached to this. And then we had a water molecule condensating out, which is why we have that water molecule here. And this is that same meeting point. So these two met here, and now we have it joined together. But what was that original? This was the alkanol, so here. And this is now our alkyl group. It's called the alkyl group because it's joined together with the actual alkanolic acid. It has 2 carbons, therefore we'll call it F. So that part is the F. And then the eel part, so that ethyl, this is because it's now an alkyl group called the ethyl, not the ethanol, we call it the ethyl. First part of the name is the ethyl. Second part of the name is originally the alkanolic acid part. We said it has 4 carbons, so it's bute. So ethyl bute. We still have the AN part. And then what happens is it's not oic acid anymore. It's butanoate. So the actual ester, this is the name of the ester. It's ethyl butanoate. This is the ester, which was formed when the 2 joined together. And then we also have this water molecule condensating out, so it's ethyl butanate plus water. And one interesting part, we said earlier, I mentioned last video, that something that increases your boiling point and melting point are these hydroxide groups. So these groups make it harder because these can cause hydrogen bonds to be formed, which increases the boiling and melting point. Because they've been removed, they've condensated out, right? So now in this here, in our ester, we have less hydroxide groups. This won't form hydrogen bonds. This still will. This won't. Which means overall, there's less hydroxide groups, which means overall, the boiling point will actually decrease. Which is why often when we make esters, even though the butanoic acid and the ethanol, even though they were liquid, the ester itself will actually be gas. It will be a volatile gas because the boiling point was lowered to the fact that there's less hydroxide groups than there were beforehand, which means there's less chance for hydrogen bonding to occur. But yeah, for this dot point, you should know, this will be one of the examples. You should know, an alkanolic acid plus an alkanol goes into an ester plus water. And then you should also realize that, how to name them. So if you're asked to actually write one out, you would figure out how many carbons there are, you would do the whole nomenclature part, which we went over in video 2, and then write the equation itself. I hope that was useful.
Thank you for watching.